In this video, we're going to focus on distance, displacement, average speed, and average velocity. But let's start with a number line so you can see the difference between the two. So let's start at position -3. And if we travel to a final position of 2, what is the distance traveled and what is the displacement? The distance traveled is simply 5 units. We traveled 5 units to the right. Now what about the displacement? The displacement is also 5. In this case, whenever you move to the right and if you don't change the direction, the distance and the displacement is the same. I'm going to use d for distance and delta x to represent displacement. Now, let's say if we start at position 4 and we're traveling to position -2. What is the distance and what is the displacement? In order to find the displacement, it's basically the change in x. It's the final position minus the initial position. The final position is -2. That's where we stopped. That's the end position. We started at 4, so that's the initial position. So it's -2 minus the initial position of 4. So the displacement is -6. Displacement is a vector. It can be positive or it can be negative. Direction is important. But now what is the distance that we traveled? The distance is always a positive value. We traveled 6 units to the left. So when describing distance, distance is a scalar quantity. It's always positive. But displacement can be positive or negative. So anytime you travel towards the right, displacement is positive. If you travel towards the left, displacement is negative. But distance is always positive, regardless if you're moving to the right or to the left. Now let's say if we started at -4 and we travel to position 5, and then after that we travel from position 5 to position -2. What is the distance traveled by the object or the particle, and what is the displacement? So let's calculate the distance first. We traveled from -4 to 5, that's 9 units to the right. And then we travel from 5 to -2, that's 7 units to the left. To find the distance, you simply add those values. So we traveled a total of 16 units. Now, to find the displacement, there's 2 ways we can do that. We could use the equation. It's the final position minus the initial position. So the final position is -2. The initial position was -4. So it's -2 minus -4, which is the same as -2 plus 4. Whenever you have 2 negative signs next to each other, you can make it a positive sign. So therefore, it's +2. So the distance traveled is 16 units, but the displacement is only +2 units. And it makes sense because we started at -4 and then we ended at -2. So the net effect is we only travel 2 units to the right. If you just compare the start and the finish, where you started and where you ended. So that's our net, that's the displacement. It's just the distance between the final position and the initial position. Now, let's break it up into 2 parts. The displacement for the first part is +9, because we traveled 9 units to the right. The displacement for the second part is -7, because we traveled 7 units to the left. If you add those 2 numbers, +9 and -7, you get the net displacement of +2, which is what we have. Now, if you want to calculate the distance, you simply make these two numbers positive. Instead of using -7, you use +7. So 9 plus 7 will give you this value, 16. So hopefully this helps you to distinguish distance from displacement. So let's say if a car travels 10 miles east and then 6 miles west, calculate the distance and the displacement of the vehicle. So if you want to calculate the distance, simply add the two numbers and make it positive. So it's just going to be 10 plus 6. So the total distance traveled is 16 miles. Now, if you want to find the displacement, you need to do it this way. When the car traveled 10 miles to the right, the displacement is positive. And then when it travels 6 miles to the left, it's negative. So you add these values, 10 plus -6. So the net displacement is 4 miles to the right. So the vehicle, it started at this point, but then it ended at this point. So the net result is that it traveled 4 miles to the right. And so that's the net displacement of the vehicle. Now let's say if a person walks 3 miles east and then 4 miles north. Calculate the distance and the net displacement traveled by the person. So to find the total distance, you simply need to just add everything. He traveled 3 miles east and 4 miles north, so he traveled a total distance of 3 plus 4, or 7 miles. Now to find the displacement, we need to find the distance between where he started and where he ended. So this is where he started, and this is his finish point, or where he ended. So we got to find the direct distance between those 2 points, and that's going to give us the displacement. So let's call it delta x, the displacement. You can call it something else if you want. You can call it s or delta y. But you know what, since we're not traveling in the x direction, we're also traveling in the y direction. Let's just call it s. What we need to do is use the Pythagorean theorem. So in this case, we know that c squared, the hypotenuse, is equal to a squared plus b squared. So s squared is going to be 3 squared plus 4 squared. So that's going to be 9 plus 16, which adds up to 25. And so the displacement is going to be the square root of 25, or 5. So the net effect is that the person traveled 5 miles in that direction, even though he actually walked a distance of 7 miles. So keep in mind, the displacement is the distance between your final position and the initial position. Now let's work on some problems. An object moves from position -8 to 12 and then to position -20. What is the total distance traveled by the object, and what is the displacement? So for these problems, feel free to pause the video and work it out yourself, and then unpause it to see if you have the right answer. So let's go ahead and begin. So we're going to start at -8. And then the object travels from a position of -8 to 12. So how far did the object travel at this time? Let's find the displacement just for the first part of the trip. To find the displacement, it's the final position minus the initial position. So the final position is 12, just for the first part, minus an initial position of -8. 12 minus -8 is the same as 12 plus 8. So right now the object traveled a distance of 20 meters to the right. Now what about the second part of the trip? How far did the object travel at that point? So the object starts at position 12 and then moves towards position -20, which should be somewhere over there. So let's calculate the displacement just for the second part of the trip. So using the same formula, delta x is x final minus x initial. So for the second part, the final position is negative 20 minus the initial position of positive 12. So that's negative 20 minus 12, which is negative 32. The negative value means that the object is moving towards the left. So now, how can we use this information to find the total distance and the net displacement for the entire trip? So to find the total distance, simply make everything positive. He traveled 20 meters to the right and then 32 meters to the left. So when dealing with distance, everything is positive. So he traveled, or the object rather, traveled a total distance of 52 meters. It's 20 plus 32. Distance is always positive. Now, if you want to find the net displacement for the entire trip, during the first part, it's positive 20. And during the second part, it's negative 32. So you got to incorporate the negative sign. So it's 20 minus 32, which is negative 12. So the displacement is negative 12, but the total distance traveled is 52. Now, you can also find the displacement using this formula. The initial position for the entire trip starts at negative 8. The final position for the entire trip ends at negative 20. So this can give us the net displacement for everything rather than just breaking up into two parts. So the final position is negative 20 minus the initial position of negative 8. So this is negative 20 plus 8, which turns out to be negative 12. So there's many different ways that you can employ to calculate the net displacement of the object. Number 2, Sally travels 50 meters west and then 120 meters south. How far did Sally travel and what is her net displacement? So go ahead and try this problem. So let's draw a picture. So let's say she started here. She traveled 50 meters west and then 120 meters south. So if you recall, this is east, this is west, this is north, and this is south. So this is where she started, and this is her final position. So therefore, if we draw a line from start to finish, the length of that line will represent her net displacement, which we can call delta S. But let's find the total distance first. So she traveled 50 meters west and then 120 meters south. So it's 50 plus 120. So her total distance is 170 meters. That's how far she actually traveled. Now to find the displacement, we just need to find the length of the hypotenuse of the triangle. So delta S squared is going to be a squared plus b squared, or 50 squared plus 120 squared. So 50 squared, that's 50 times 50, that's 2,500. And 120 times 120 is 14,400. So if we add these two numbers, this is going to give us 16,900. So now let's take the square root of both sides. The square root of 16,900 is 130. So that is Sally's net displacement. That's the distance between her initial position and her final position. And so that's the answer for part B. Let's work on number 3. Megan walks 100 meters east and then travels 70 meters north, followed by 140 meters east. Calculate the total distance and net displacement. So she travels 100 meters east and then she's going to travel 70 meters north, and then 140 meters east. So to find the total distance, we just need to add the numbers. 100 plus 70 plus 140. 70 plus 140, that's 210, plus 100, that's 310. So that's the total distance traveled by Megan. Now, to find the net displacement, let's draw a line from her initial position to her final position. How can we find that distance? So what I'm going to do is I'm going to redraw it. I'm going to draw this vector first and this one right after it. So this problem is equivalent to this problem. Let's say if she traveled 100 meters east, and then another 140 meters east, and then 70 meters north. Now notice that we have a right triangle. Our goal is to find the length of this green line, which we can call delta S. So if we add these two numbers, 100 plus 140, that's 240 going east, and then 70 going north. So now we could use the Pythagorean theorem. So delta S is going to be the square root of 70 squared plus 240 squared. And you could type it in exactly the way you see it in your calculator. So you should get 250. That is her net displacement. That's the distance from the initial position to her final position. It's 250 meters in that direction. Here's another example. Jared walks 120 meters east, and then 150 meters south, and then 40 meters west. Let's start by finding the total distance. So all we need to do is add 120 plus 150 plus 40. 120 plus 150, that's 270, plus 40, so that's 310 meters traveled. So it's very simple to find the total distance. You just got to add the numbers. Now we got to find the displacement, which is the distance between the initial and the final position. So how long is the blue line? So here's what we're going to do. We need to turn this into a triangle. So if he traveled 120 meters east and then 40 meters west in the x direction, his net displacement is only 80 meters to the right. So this is positive 120 and this is negative 40 in the x direction. If you add those two, that's going to give you positive 80 in the x direction. In the y direction, there's only one number, 150, so we can't do anything with that. So now we could find the hypotenuse. So the displacement is going to be the square root of a squared plus b squared, or 80 squared plus 150 squared. So if you type that in exactly the way you see it, this should give you 170. It's based on the 8, 15, 17 right triangle. So that's the net displacement of Jared. It's helpful to know the special right triangles because if you know them, you can quickly solve certain Pythagorean theorem related problems. The first one is the 3, 4, 5 right triangle. So if you see another triangle where this is 30 and this is 40, you know the missing side has to be 50. So there's the 3, 4, 5 right triangle. There's the 5, 12, 13 triangle. So this is 50 and this is 120. The missing side is 130. The next one is the 8, 15, 17 right triangle. And then the 7, 24, 25 right triangle. Those are the most common ones that you may encounter. Some other rare ones you might see is the 9, 40, 41 triangle and the 11, 60, 61. Other than that, I doubt you'll see anything else. But you can see any ratio of these numbers. For example, the 3, 4, 5 triangle, if you multiply it by 2, you'll get the 6, 8, 10 triangle. So if this is 60 and this is 80, the missing side is 100. So if you know these numbers, then you could solve a lot of common right triangle problems quickly. Now let's talk about the difference between average speed and average velocity, as well as how to calculate them. Now keep in mind, speed is a scalar quantity. It has magnitude only and no direction. Velocity is a vector quantity. It has both magnitude and direction. So velocity is basically speed with direction. Now if you want to calculate average speed, we'll indicate average with a bar on top of the S. Average speed is equal to the total distance traveled divided by the total time. Average velocity is equal to the displacement divided by the time. So displacement is a vector, therefore velocity will be a vector. Distance is a scalar quantity, so speed will also be scalar as well. Now, speed, that is instantaneous speed, is the absolute value of velocity. So what this means is that speed will always be positive. Velocity can be positive or negative depending on the direction. So for instance, let's say if Karen is traveling at a speed of 30 miles per hour east. Karen's speed is 30. Her velocity is 30 miles per hour east. The units are the same. So as you can see, velocity is speed with direction. Now let's say Jim is traveling at a speed of 40 miles per hour west. So his speed at that instant is positive 40 miles per hour. So in both cases, if a person is traveling east or west, the speed is positive. Now because this person is going in the negative x direction, the velocity will not be positive. The velocity is negative. So his velocity is negative 40 miles per hour in the direction west. So as you can see, speed is always positive, but velocity can be positive or negative depending on where a person is going. So make sure you understand that concept. Now let's work on some practice problems. A car travels a distance of 300 miles in 6 hours. What is the average speed of the car? So we could use this formula. The average speed is going to be the distance traveled divided by the time. So the distance is 300 miles. The time is 6 hours. So what's 300 divided by 6? Well, we know that 30 divided by 6 is 5. So 300 divided by 6 is 50. So we get 50 miles per hour, or we can write it as 50 mph. So that's it for number 1. That's how you can calculate the average speed. And you can get the units by looking at the units of distance and time. Let's go ahead and solve these two problems. A car travels at an average speed of 40 feet per second. How many miles will it travel in 5 hours? So we could use the formula d is equal to rt, distance equals rate times time, or d equals vt, where v is the rate, average speed, average velocity. So it will lead to the same answer, regardless of which of those two formulas you decide to use. But let's write down what we know. So we know the average speed is 40 feet per second. We know the time is 5 hours. Our goal is to calculate the distance. Now we don't want to plug it into that formula right now because the units, they don't match. So what should we do here? We want the distance in miles and we have the time in hours. So in order for the units to match, we need to convert the average speed from feet per second to miles per hour. And then we could plug everything into the formula. So let's go ahead and do that. So we have 40 feet per second. The first thing you need to be familiar with is the conversion between miles and feet. 1 mile is 5,280 feet. So I'm going to put the unit feet on the bottom and 1 mile on top so that the unit feet will cancel. Now let's convert seconds into minutes. There's 60 seconds in 1 minute. And so we could cross out the unit seconds. And there's 60 minutes in a single hour. So that's how we can convert from feet per second to miles per hour. Now let's go ahead and plug this in. So it's 40 divided by 5280 times 60 times 60. So the new value of V is 27.27 repeating miles per hour. So now let's go ahead and calculate the distance. The distance is going to be the speed multiplied by the time. So V is 27.27. We have miles on top, hours on the bottom. And then we're going to multiply it by T, which is 5 hours. So we can see that the unit hours will cancel. So 27.27 repeating times 5. That's 136.36 repeating miles. So that's how many miles this car will travel in 5 hours. Now let's move on to part B. A train is moving at 45 kilometers per hour. How long will it take for the train to travel a distance of 20 miles? So let's write down what we know. We know the distance is 20 miles. How long? So we're looking for the time. And we're given the speed. It's 45 kilometers per hour. Now, we can change the speed from kilometers per hour to miles per hour, or we could change the distance from miles to kilometers. We can do it both ways, but the key is that these two, they need to match. So this time, let's change the distance. The conversion between miles and kilometers is this. 1 mile is 1.609 kilometers. You can look this up online as well. So it's 20 times 1.609, and that gives us a distance of 32.18 kilometers. So now let's go ahead and use this formula. D is equal to VT. We need to isolate T. To do that, let's divide both sides by V. So time is distance over average speed. So this train is going to travel a distance of 32.18 kilometers. And its average speed is 45 kilometers per hour. So we can see the unit kilometers will cancel, and the time is going to come out in hours. So 32.18 divided by 45. This is 0.7151 repeating hours. Now, if we multiply this by 60 minutes per hour, we can get the answer in minutes, which we could say it's approximately 42.9 minutes. So that's how we could find the time if we know the distance and the average speed.